So, hello students, this is a DC generator numerical. It has already been asked in your examination. So, how to solve this question? So, the question statement is like an 8-pole DC generator has 500 armature conductors and has a useful flux per pole of 0.065 Weber. What will be the EMF generated if it is lap connected and runs at 1000 RPM, 1000 revolutions per minute? So next is asking that what must be the speed at which it is to be driven to produce the same EMF if it is wave bound, if it is wave connected. So how to solve this kind of numerical? See, we have derived the armature induced EMF expression, that is EA is equal to P phi NZ by 60A, right? For the first case, let us calculate the induced EMF in the armature, because he is asking the generated EMF in the armature in the first case. So EA1 is equal to P phi NZ by 60A. P is the number of poles of the machine, phi is the flux per pole, N is the rotational speed, right, in revolution per minute, Z is the total number of armature conductor, and A is the total number of parallel paths. So rearrange the terms like this: phi Zn by 60 into P by A, right? Now for the very first case, he is saying that the machine is lap connected, the generator is lap connected. So I told you that in the derivation that for lap connection, the number of parallel path will always be equal to number of poles in the machine. So A is the number of parallel path, P is the number of poles. So for lap connected windings, A is equal to P, right? So P and A, they get cancelled for the lap connection, right? So finally you are left with phi Zn by 60. So put all the values. Flux per pole phi, it is given as 0.065 Weber, right? 0.065 Weber, right? And that Z is the total number of armature conductor, that is given as 500. So you write 500 here. Then N is the rotational speed, that is given as 1000 RPM. So write here 1000 divided by 60. So you will get E1 is equal to 541.67 volts, right? Now for the second case, he is saying that for the same induced EMF, for the same EMF in the armature, you will have to calculate the rotational speed, right? So let me use the same formula. E is equal to P phi NZ by 60A, and let me write in the second case the speed is N dash, that you have to calculate for the second case, right? N dash, right? For the second case, that is speed you will have to calculate, right? So here write the same formula and just calculate for the same EMF, that is 541.67. calculate the speed at which it is rotating for the next case, right? So EA2, let me call this induced EMF EA2, which is nothing but EA1, because he is same. For the same EMF, you will have to calculate the speed, right? So EA1 is equal to EA2 is equal to P phi N dash Z by 60A. From here you calculate the rotational speed, that is 60 A EA1 divided by P phi Z, right? So 60 number of parallel path in the wave connection, you know that it is equal to 2, right? For the wave connected armature, right, you know that number of parallel path will be equal to 2 only. So A is equal to 2. So you write here A is equal to 2, EA1 is equal to 541.67, that you have already calculated, put here, right? And then P, number of pole, that is 8, it is given as 8 pole DC generator, right? Then flux per pole is again the same, it is 0.065, and number of armature conductor are already 500, so you put 500 here. Solve this, use a calculator, you will get 250 rpm, 250 revolution per minute, right? So for the next case, for the wave connected armature, for the wave connected machine, for the same induced EMF, if it is wave connected instead of lap, then it will rotate at 250 rpm, right? So 250 rpm will be the answer, 250 revolution per minute. So for all such kind of video, just subscribe to this channel. Thank you very much.